I'm talking about the importance of BPG. That's the word 2,3-biphosphoglycerate. That's the importance of the formation of this 2,3-biphosphoglycerate in the Rapoport-Leubering cycle. So looking at this question, this was just how the question was asked. So discuss briefly the importance of what? BPG formation in the Rapoport-Leubering cycle. Now, first of all, if you don't know what is BPG, you have failed the question. And another thing is the Rapoport-Leubering cycle is one of those cycles that is usually neglected in biochemistry. So students that will always get this type of questions are students that have gone through the past questions, because I remember throughout my time in biochemistry, they didn't even teach us about this cycle. So if not for past questions, I wouldn't have known that something like this actually exists. All right. So past questions are important. So we're actually talking about this 2,3-biphosphoglycerate. Let me go to the next picture. It's quite clearer. 2,3-biphosphoglycerate. The whole pathway you are seeing here is actually what the Rapaport-Leubering pathway. All right. So we are saying this 2,3-biphosphoglycerate is formed in this pathway, and what is its importance? Okay. So we are saying what the Rapaport-Leubering path cycle is also known as a Rapaport-Leubering shunt. It's actually a metabolic pathway in mature erythrocytes. It will now start taking your mind back toward blood physiology. What is the role of blood? Transportation of oxygen. What's in blood actually transport oxygen? It's actually hemoglobin. You get. So it's a pathway in mature erythrocyte. That means if your red blood cells have not reached maturity, they won't have this cycle. Do you understand? That's how you actually link things. So this pathway is where this 2,3-biphosphoglycerate is produced. All right. So that's what they actually call the BPG. All right. So what are the importance of this BPG? This BPG actually regulates what oxygen release. So if oxygen is bound to hemoglobin and is being transported, what will make that oxygen to be released from that hemoglobin to be delivered to cells that actually need oxygen? It's actually this word 2,3-biphosphoglycerate. So it's such an important guy that has been neglected. All right. So the 2,3-biphosphoglycerate binds to hemoglobin and decreases its affinity for oxygen. So it will decrease the love that hemoglobin has for oxygen, making the hemoglobin release the oxygen to cells that actually need it the most, right? So this allows hemoglobin to release oxygen more readily to tissues, especially under conditions of what low oxygen levels. That's what we call hypoxia, right? They also aids in what adaptation to high altitudes. So in high altitude environments, the body produces more of this what biphosphoglycerate, okay, so that it also is facilitate what oxygen release, make much more oxygen to be released, right? Helping to compensate for the lower oxygen that will be available at high altitudes, right? So like for example, when you go to Jos, all right, when you go to Jos, there's a way like very, very tall mountains, all right, that when you climb there, you feel like you are losing your breath. But after some time, you actually what balance up, right? That means there's much more production of this, all right? Then it also maintains oxygen delivery. So by modulating the hemoglobin oxygen binding properties, the 2,3-biphosphoglycerate ensures that efficient oxygen is being delivered to different tissues, which is actually essential for cellular respiration and energy production, right? So that's it.